Lesson 6a, Work. Work is assigned the symbol capital W. It is a measure of how energy is used or how energy is transferred. For a force to do work on an object, it must act on the object and move it a distance, or displace it, in the direction of the force. It is a scalar value, which means it does not include direction, simply magnitude. That means a negative and positive value will mean loss or gain when calculating work, not direction. The formula for work is force times displacement, and is often shortened to F times d. Its SI unit is the joule, uppercase J, but can sometimes be written as Newton meters or kilogram meters squared per second squared. Let us take a look at an example. A 25 Newton force acts on a block to move it 10 meters forwards. Here's the box. There's 25 newtons of force applied, and the box moves forwards 10 meters. What is the work done on the block by the applied force? Well, the work equals force times displacement. That is 25 times 10, which makes work equal to 250 joules. In order for work to occur, the force must move the object, so no motion means no work, regardless of the magnitude of the force applied. Here's an object with an applied force of 1,000 newtons. The force is not enough to move the object. Work is F times d. That's 1,000 times 0. Work done by the applied force is 0. Regardless of the size of the applied force and what you feel applying the force, if you do not move the object, you have done no work on the object. Work is a scalar value, which means it does not include direction. So when you calculate work and you end up with a positive value, it means that the applied force on the object moved the object in the direction of the force, and you did work on the object. An example of this is a falling rock. The force of gravity acts to pull the rock downwards. The rock displaces downwards. A negative times a negative makes a positive. The work done by gravity on the falling object is positive. In the case of your work calculation, resulting in a negative value, this only occurs when the direction of force applied and the displacement of the object are in opposition. We can use a rock as an example of this as well. But this time the rock does not fall, rather it rises due to an applied force. If we look at the effect of force gravity on the rock, which pulls the rock downwards, the displacement of the rock is upwards. This means that the work done by gravity on the rock is negative. A positive times a negative is negative. However, the work done by the applied force lifting a rock must be positive. So back to our first example, where we moved the block 10 meters in the direction of our 25 Newton force. Work done by the applied force is 25 times 10, which makes positive 250 joules. The positive sign means that the force applied did positive work on the box, meaning the box gained energy from the applied force. Positive work only happens when the applied force is in the same direction as displacement. Example number 2. How much work is done by a 35 Newton friction force on the block as it moves 10 meters? Our drawing shows a 25 Newton applied force and a 35 Newton friction force. Our box moves to the right 10 meters. Work due to friction force is force friction times displacement, negative 35 times 10. The negative on the friction force, which is a vector, means it opposes motion. Work due to friction is negative 350 joules, because friction force was opposite to the direction of motion. What this means is that the block lost energy due to friction. It is not direction, although direction is used to determine the sign.